In the previous class, we had already studied about a microscope and its working. Now today there is a question how to achieve a large magnification for a microscope, or how do we increase the magnification of a microscope. For that, I want you to remember this formula: magnification M is equal to L by FO into D by FE, where L stands for the tube length, FO focal length of the objective, FE focal length of the eyepiece, and D 25 centimeter least distance of distinct vision for your eye. So how can you increase the magnification? To increase the magnification, we have to adjust these four terms, of which D is a constant, 25 centimeter for a normal person. So the remaining is these three terms. For this total value to increase, that means to increase magnification, you have to decrease the terms in the denominator and increase the terms in the numerator. I told you D cannot be changed, so you have to increase this value and decrease these two values. So to increase the magnification of a microscope, you have to decrease the focal length of the lenses that we are using, that is focal length of the objective and eyepiece. But remember, that is a minimum value beyond which you cannot decrease the focal length. And another method is increase the tube length L. For that you have to use large lenses. So this is the method how we can increase the magnification of a microscope. Now let us see what you mean by dispersion. The splitting of white light into the component 7 colors when white light passes through a prism is called dispersion. Now let us see what is the reason for dispersion. Answer: refractive index N, we represent it by N, for a medium is different for different colors. We know that white light consists of 7 colors, and the refractive index of a medium is different for different colors or wavelength. Color of a light is different because each color has got different wavelength. So refractive index is different for each wavelength. That is the reason for bending. Red light bends the least and violet light bends the most. So when white light passes through a prism, after bending you can see that violet bends more than red light, and the remaining colors comes in between, which are violet, indigo, blue, green, yellow, orange, red. Red is bending the least and violet bends the most. Now due to dispersion, there is a problem arising in lenses. That term is called chromatic aberration, and it is mentioned in page 333 in your textbook. Please read that portion. What do you mean by chromatic aberration? When white light passes through a lens, a convex lens, after refraction it bends and meets at a point. That point is called focus. But if the lens is quite thick, നല്ല വണ്ണമുള്ള ലെൻസ് ആണെങ്കിൽ, thick lens ആണെങ്കിൽ, this thick lens acts like a prism. So when white light passes through this kind of thick lenses, after passing through this lens, slight dispersion takes place. So instead of meeting at one point, white light splits into different colors. So you do not get a focus, correct focus. The light becomes blurred, B-L-U-R-E-E-D, blurred. You get a blurred image. What is the reason? This is due to the bending of different colors to different points. ഇപ്പോൾ ഒരു ക്ലിയർ ഫോക്കസ് ഒറ്റ പോയിന്റിൽ കിട്ടുന്നത് പോലെ തിക്ക് ലെൻസുകളിൽ ഒരു ക്ലിയർ പോയിന്റിൽ ഫോക്കസ് ആകുന്നില്ല. ഈ കുഴപ്പത്തിനാണ് എന്തെന്ന് പറയുന്നത്? ദാറ്റ് ഇസ് കോൾഡ് ക്രോമാറ്റിക് അബറഷൻ. ഇറ്റ് ഇസ് ഡ്യൂ ടു ദ തിക്നെസ് ഓഫ് എ ലെൻസ്. തിൻ ലെൻസിൽ ഈ പ്രശ്നമില്ല, തിക്ക് ലെൻസിൽ മാത്രമേ ഈ പ്രശ്നമുള്ളൂ. ഓക്കെ, so to avoid chromatic aberration you have to always use thin lens. So I hope you have understood the term chromatic aberration. And does dispersion takes place in all the medium? No. എയറിൽ കൂടി വാക്വത്തിൽ കൂടി പോകുമ്പോൾ ലൈറ്റ് ഇങ്ങനെ സ്പ്ലിറ്റ് ആകുന്നുണ്ടോ? ഇല്ല. സോ എയർ, വാക്വം എക്സെട്ര ആർ കോൾഡ് നോൺ ഡിസ്പേഴ്സീവ് മീഡിയം ആൻഡ് ഗ്ലാസ് ഇസ് കോൾഡ് ഡിസ്പേഴ്സീവ് മീഡിയം. Next, let's move on to the working of a telescope. What is a telescope used for? It is used to provide magnification for very distant objects. So let us compare that with a microscope. Microscope is used to magnify an object that is very close, but telescope is used to magnify objects that are very distant. ഒരുപാട് ദൂരെയുള്ള സാധനങ്ങളെ വലുതായിട്ട് കാണാനാണ് ടെലസ്കോപ്പ്. മൈക്രോസ്കോപ്പോ അടുത്തുള്ളതിനെ വലുതാക്കി കാണാൻ. സോ ഇൻ എ ടെലസ്കോപ്പ് ഓൾസോ there is objective lens and eyepiece lens. So when you compare with a microscope, in telescope the objective lens is bigger than the eyepiece lens. Now let us see the ray diagram for a telescope. This is the ray diagram. This is the objective lens. Objective lens എന്ന് പറഞ്ഞാൽ എന്താണ്? That is near the object. ഇവിടെ object എന്താണ്? ടെലസ്കോപ്പിൽ കൂടി usually you observe very distant stars, planets, etc. Okay, so for that in the ray diagram how do we mark a very distant object? ഒരുപാട് ദൂരെയുള്ള ഒബ്ജക്ട്സിനെ we usually draw two parallel lines. When two parallel lines passes through this convex lens, what happens? When it passes through this point, it passes straight. Another point, it bends and passes through the focus and it meets here. This is the focal point of the second lens. This lens is close to the eyes. So what is the name of this lens? Eyepiece. Objectinte അടുത്തുള്ള objective, ഐയുടെ അടുത്തുള്ള eyepiece. Okay, and this total distance is called tube length, FO plus FE. Okay, and magnification of a telescope is given by magnification M is equal to beta by alpha. What is beta and alpha? Angle subtended by the image to this lens by angle subtended by the object. So it's marked in the diagram. This is alpha, this is beta. Let us see what are the values of alpha and beta from the diagram. Beta is equal to h by fe. Beta is angle subtended this side. So this is approximately equal to h by this distance. And alpha is h by fo. So this is an approximate value. When you divide, you get it fo by fe. Okay. So this is the magnification of a telescope. So let us compare this with microscope. Microscope, the objective was small, eyepiece was big. Here it is the opposite.